Hi, I'm Boya. I'm presenting to you today our NeurIPS paper, Understanding Bias in Large-Scale Visual Datasets. This is joint work with Yida and Zhuang. When we say visual dataset, what comes to your mind? For many people, I'm guessing it might be MNIST. Since MNIST was proposed in 1998, we as a community has been pushing the boundaries of computer vision by collecting more and more diverse datasets. This leads to Cypher in 2009 and ImageNet in the same year. Fast forward to the year 2024, the community has curated a wide range of large visual datasets with the purpose of pre-training. Three representative ones are YFCC, CC, and Datacom, abbreviated as YCD. Given how comprehensive these modern datasets are, we wonder, are they general enough to represent the universal visual world? Back in 2011, Toroba and Nerfros proposed the Name That Dataset experiment, which is a classification task where SCMs are trained to predict the dataset origin of images. The datasets back at the time turned out to be classified very well, with 39% accuracy for 12-way classification. A decade later, Liu and He revisited the problem and found that modern datasets can still be classified accurately by modern neural nets. This shows us that these large-scale datasets are still very biased. But the question remains, what are the concrete forms of visual bias among these datasets? We apply various transformations to extract different types of information from datasets and then perform the classification task on the transformed images. This can help us understand how each type of information contributes to the dataset bias. Let's start from semantic segmentation mask. It provides fine-grained semantic annotation but removes texture. The dataset classification accuracy on these masks could show how semantically biased these datasets are. Take a guess what the accuracy would be. I'll wait. It turns out, semantic segmentation mask gets us a dataset classification accuracy of 67%. What if we instead completely remove visual information and use VLM-generated captions to represent semantics? The accuracies are still very high. On top of these transformations that seek to preserve semantics, we also try to use VAE to hopefully remove low-level signatures. This doesn't decrease the accuracy much from the 82% on original images. These high dataset classification accuracies on semantics tells us that semantic bias is an important component of dataset bias. Next, we analyze the dataset bias in object shapes. Using SAM to outline object boundaries brings us to quite a high accuracy of 73%. Also, if we look at spatial geometry through depth estimation, the transformed images turned out to be classified very well as well. Thus, object shape and spatial geometry variations are significant among YCD. To see further how much bias is captured in spatial information, we shuffle the pixels to disrupt spatial coherence. We either shuffle images with a random order or use a fixed order across all images. The accuracy drops a lot from the original 82%, but it's still better than chance. But if we divide the images into patches of size 16 and shuffle the patches instead, the accuracy in fact doesn't go down from the 82% on original images. Therefore, completely destructing the local structures can largely reduce dataset bias, and patch-level local structures suffices to identify dataset signature. Now, what if we just average the RGB values across all pixels in an image? These simple color statistics can still lead to non-trivial classification accuracy. If we look at the distribution of main RGB channel values across all images, we can see that YFCC is darker than CC and Datacom. Synthetic images have great potential for augmenting data, so we want to know if dataset bias can be inherited from diffusion models training images to its generated images. We trained one unconditional diffusion model on each dataset and found that their generated images can be classified very well. The upshot here is that synthetic images can indeed inherit the bias in diffusion models training images. We could also sample synthetic images from a pre-trained text-to-image model based on the VLM captions of YCD images. By converting images to captions and then back to image modality, this process only retains the semantics captured in captions. Thus, this accuracy further confirms that semantic bias is a major contributor to dataset bias.
So far, we find that semantic bias is very important in YCD datasets. Can we go one step further and explain in detail? To this end, we analyze semantic bias on object level. We apply models pre-trained on other vision benchmarks like ImageNet, Elvis, 8020K to provide object annotation for each image. Here, we'll compute the number of images in each dataset that contain a particular object class. We can see there is a considerable imbalance in object-level distribution across datasets. For instance, more than 60% of images containing the Elvis class water bottle are from YFCC. Overall, YFCC emphasizes outdoor infrastructure, while CC and Datacom contain more images of household items and a product showcase. The general caption can also serve as semantic representations for images. From there, we can leverage various natural language methods to analyze the dataset. Using classical topic discovery method on caption will let us find key concepts for each dataset. We can see YFCC is mostly characterized by auto things. CC and Datacom have more emphasis on digital graphics. We can also prompt large language models to summarize each dataset's characteristic by providing caption. The general output is shown here. We again see that outdoor, natural, and human-related things are highlighted for YFCC. Static object and digital graphics are represented for Datacom. CC, on the other hand, blend both of their elements. In summary, we propose a framework to understand the concrete form of bias in large-scale datasets. We use transformation to quantify bias in each type of information with dataset classification. We then decompose semantic bias with object and natural language analysis. We showcase our framework on YFCC, CC, and Datacom. We hope our work can help understand dataset bias and improve dataset diversity in the future.